Math Blast 7. I understand place value relations. Write the value of the 2 in each number. 7,261 has 2 hundreds, which is equal to 200. 4,752 has 2 ones, which is equal to 2. Compare the value of the 2 in each number. So going from 2 to 200, I know that each time a digit shifts to the left on the place value, it becomes 10 times greater than that same digit to the right. So this 2 shifts to the tens place would be times 10, and then to shift over to the hundreds place would be times 10 again. So times 10 would be 100 times as much. So we're going to say that 200 is 100 times as many as 2. I can write numbers in different forms. The standard form, base 10 numerals, is given to us. It's 352,947. I'm going to write that number in unit form. So I'm going to tell the unit of each of my digits here. 300 thousandths. I'm going to abbreviate. 5 ten thousandths. 2 thousandths. 9 hundredths. 4 tens. And 7 ones. In expanded form, I'm going to use my unit form. Since I told the unit form for each digit, I'm just going to write the value of each of those added together. So 300,000 plus 5 ten thousandths is 50,000 plus 2,000. We're going to put my sign down here. Plus 900 plus 4 tens is 40 plus 7. I can model equivalent fractions. Model 1/4. Draw additional lines to create an equivalent fraction. What equivalent fraction did you create? So to model 1/4, I have one part that will be shaded out of 4 equal parts in the whole. So let's go ahead and make the 4 equal parts in the whole here. The denominator in my fraction tells me the equal parts in the whole. The numerator tells me how many of those parts I want shaded here. So I've represented 1/4. Now I'm going to draw additional lines to come up with an equivalent fraction. And I could draw as many additional lines as I want. Vertically or horizontally here, I'm going to draw 2 additional lines. And so now I'll notice that my 1 shaded part has become 3 shaded parts. And out of the whole, instead of having 4 equal parts in the whole now, I have 12 equal parts in the whole. So I can say 1/4 is equal to 3/12. On the back side, I can determine the perimeter and area of a rectangle. Determine the perimeter and area of the rectangle below. Perimeter has this key word here for me, rim. I know that I need to go around the distance around the figure to determine the perimeter. So I'm going to start at one corner here and I'm going to go all the way around it. So I have 5 centimeters plus 10 centimeters. Opposite sides in rectangles are equal, so this is going to be 5 centimeters. And this top side here will be 10 centimeters. So I can add those all together. 5 centimeters plus 10 centimeters plus 5 centimeters plus 10 centimeters equals 30 centimeters. So that's going to be my perimeter. Now for area, I'm finding the two-dimensional surface, and so here I want to figure out, well, how many squares would it basically take to cover that two-dimensional space that covers the figure. So I would have basically 10, if I wanted to draw this out, I would have 10 columns. So there's 10 columns there, and then I would have 5 rows. And I could count all of those squares. But I don't need to do that if I know that the total number of squares that cover that two-dimensional space there is equal to the length times the width. So I can say the area is 10 centimeters times 5 centimeters, which is equal to 50 square centimeters. And that's going to be the area. Whoops. All right. I can identify types of angles. Classify the angles as acute, obtuse, or right. So here I have a 43-degree angle. I know a right angle measures exactly 90 degrees. An obtuse angle measures more than 90 but less than 180 degrees, while an acute angle measures less than 90 degrees. So our given angle of 43 degrees is categorized as acute. That's all for today, math friends.